All right, we're looking at Geometry A, Unit 2, the unit activity. In Task 1, what it wants us to do is to be able to show if a few pieces of information is enough to prove that two triangles are congruent. And so what we want to do is, in this first one, if one side and the side next to it and the angle next to that, if those are all the same, can we make only one triangle with exactly those things, or can we make multiple triangles that have those exact things? Okay, so if we go to GeoGebra, we're just going to go ahead and make a random triangle. Now it said here a hint. Try constructing a triangle where the known angle is opposite to the shortest known side. So we're going to have a short side over here, and then a couple long sides. And so what we want is to prove that this side and this side and this angle, they have to be in that order, that's what we're using. So if there's only one triangle that we can make with these three pieces of information, then awesome, then it works. But if we can make multiple triangles with these exact same pieces of information, then it does not work. So let's go ahead and measure our angle right here. So we're going to do A, B, oops. You can do it that way. Let's go ahead and do it this way. There we go. Okay, and let's move this. So 85.74. This angle needs to stay the same the whole time. And, oops, I'm sorry, I actually did the wrong angle. Let's do the angle up here, like I said. Alright, so I'm going to measure this way, not that way, this way. Alright, and we'll move that. So 15.29, that needs to stay the whole time. This side length needs to stay the same. This side length needs to stay the same. So what we're going to do is we're going to keep A and this S the same, but we're going to take this one and make a new one. And so let me show you what I mean by that. We want to find out the measure of this line segment here. Since it's the segment across from angle C, this is called segment C. So when we look here at segment, if we find C, we're going to make a segment that is exactly like this, and we're going to move it around. So we want to create a segment that's 2.23. Oh, keep making little mistakes. Segment with given length. There we go. It says select point, then enter length. It's going to be 2.23. 2.23. All right, now we're going to move this around. Now if we can make a triangle out of these pieces of information, including this segment, which is the same length as that, okay, so we're not changing that, then we're going to be able to prove this wrong. So I'm going to put this here, because now it's maintaining the length of this, and it's maintaining the angle. And I'm going to move this, bam, right here. We have now created a different triangle, right? CDE, we've created a different triangle that has the angle and this side and this same side length, but it's a new triangle. All right, so this right here would be our counterexample to show that side-side angle does not mean that you can only create one triangle with those pieces of information. We just created two. All right. Okay, now the easiest way to do this one with angle, 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 because trust me, if you're just trying to make triangles that have the same angles, it's going to be very tedious and very frustrating. So what we're going to do is we're going to create a triangle. Let's make a small one. And then we'll need to create a point. Let's just stay over here, because what we're going to do is dilate. So dilate from a point. It just says select object, then center point, and enter factor. Here's our object. Here's the point we want to use. Let's use a factor of, let's say, 2. And so now, oops. Let's look here. Okay, so when we dilate, it should keep all the angles the same, but we need to show that. So you always want to be moving counterclockwise when you're measuring angles. So, oops, actually it's set for clockwise, my bad. Here we go. Alright, so we've measured those angles. Let's measure these ones. right, and we can see that all three are the same. And we know that these are not congruent triangles because congruent triangles are all exactly the same lengths and everything. So this is saying that even if we know that all three angles here are the same as all three angles here, it does not prove that these triangles are congruent. Okay, now for this last one, side angle, angle, it has to go exactly in that order. So I already made it over here. I just made a triangle. I labeled side angle, angle. I measured the side. I measured the two angles. Now, if we know that these two angles are what they are, this angle, there's only ever one choice for this angle because a triangle always has 180 degrees. So if you know two angles, you have to know the other one. So let's just measure that. Okay, so like what we just showed, if all the angles are the same, what we could do is dilate this. But what will happen when we dilate is that this side will change, but we can't have the side change. So the only way to maintain all the angles is to dilate the whole thing. But once we dilate it, it'll change the side. So side angle, angle is a way for us to prove that triangles are congruent.